Hello there. Here's your lesson for Unit 2, Section 3 on deductive reasoning with Missy McCarthy, math instructor at Okemos High School. Deductive reasoning is the process of using logic to draw a conclusion from given facts, definitions, or properties. Deductive reasoning is different than our previously discussed inductive reasoning because inductive reasoning simply uses patterns to draw a conclusion, while deductive reasoning uses facts, definitions, and properties. Here's just a little animation here that says penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Not very good use of logic and deductive reasoning by this penguin. So let's take a look at these particular examples and determine whether or not they are examples of inductive, which is drawing a conclusion based on a pattern, or deductive, which is drawing a conclusion based on facts, logic, and properties. There's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, the myth is false. So we're not trying to determine whether or not it's true or false. We're just trying to determine whether or not they used inductive or deductive reasoning. And for this, because they just used a series of events that happening based on the pattern, they're determining that it's false. So this would be an example of inductive reasoning. For the next one, it says, there's a myth that the Great Wall of China is the only human-made object visible from the moon. The Great Wall is barely visible in photographs taken 180 miles above the Earth. The moon is 237,000 miles from the Earth. Therefore, this myth cannot be true. So because this uses facts and logic and properties, it is an example of deductive reasoning. Okay? In deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. So the law of detachment says if P implies Q is true, and then we know that P is true, then the only logical conclusion to draw is that Q is true. For example, if I tell you if it's raining, then the ground is wet, and then somebody runs in and says, it's raining, the only logical conclusion that you can draw is that then the ground must be wet. So that's an example of the law of detachment, which is a valid use or form of deductive reasoning. So we're going to determine if this conjecture is true using the law of detachment. Again, the law of detachment says if P then Q is true, if that's one thing that's true, and then they tell you that P is true, then the proper conclusion to draw is that Q is true. So here we're given if the side lengths of a triangle 5, 12, and 13 are 5, 12, and 13, then the area of the triangle is 30 square centimeters. So our P is that the side lengths are 5, 12, and 13, and our Q is that the area is 30 square centimeters. Then we're told that the area is 30 square centimeters. So we're actually being told here that Q is true. So then we can draw the conclusion that PQ and R have the side lengths 5, 12, triangle PQR has side lengths 5, 12, and 13 centimeters. So that is P is true. So this does not follow the law of detachment because the law of detachment says P then Q is true. P then Q is true. then P is true, but here we're given that Q is true. So it would be an invalid use of the law of detachment. Invalid use of that as a valid form of reasoning. Again, we're not judging whether or not the statements are true or false, just whether or not we're using this form of deductive reasoning properly. Okay, let's try this one. In the World Series, if a team wins 4 games, then the team wins the series. The Red Sox won 4 games in the 2004 World Series. Therefore, we can conclude that the Red Sox won the 2004 World Series. So let's see if this follows our law of detachment. Okay, if a team wins 4 games, that is P, then the team wins the series, that is Q. The Red Sox won 4 games. They're telling us that P is true. So the conclusion or the conjecture is that the Red Sox won the 2004 World Series, and that would say that Q is true. And yes, this is a valid form of the law of detachment, one way of using deductive reasoning. Another form of deductive reasoning is the law of syllogism. The law of syllogism says if P implies Q and Q implies R are both true statements, then P implies R is also a true statement, so we can cut out Q. For example, if the team wins tonight, then they will go to the championship. If they go to the championship, there will be a game on Friday. So that if the team wins tonight would be P, then they will go to the championship, which is Q. If they go to the championship, then the game will be played on Friday. That will be Q to R. So our conclusion that can be drawn is if the team wins tonight, then they will play in the game on Friday. That would be an example of the law of syllogism. So let's see if this is a valid use of the law of syllogism. If angle A measures less than 90 degrees, then angle A is acute. So this would be P and this would be Q. If angle A is acute, that's Q, then it is not a right triangle. That's something new, so we're going to call that R. So our conjecture is if the measure of angle A is less than 90, which is P from up here, then it is not a right angle, which is R. So yes, this is a valid use of the law of syllogism. P implies Q, Q implies R, P implies R is our conjecture. So let's try this one. It says given if a number is divisible by 2, that's P, then it is even, that's Q. If a number is even, that is Q, then it is an integer, that would be R. So P implies Q, Q implies R. We're looking for P implies R. So our conjecture should say if a number is divisible by 2, then it is an integer. Let's see if it says that. If a number is an integer, then it is divisible by 2. This is R implies P, which is an invalid use of the law of syllogism. Okay, so let's use deductive reasoning in one of our laws to draw a conclusion about this statement here. If triangle LMN is translated in the coordinate plane, then it has the same size and shape as its pre-image. If an image and pre-image have the same size and shape, then the figures have equal perimeters. So we're now told that triangle LMN is translated in the coordinate plane. So that would be telling us that P is true. So our conclusion has to be P implies R. So if this is P, and then this is Q, and then this is Q, and this is R, our conclusion is the pre-image and image have equal perimeters. And there we were using the law of syllogism.